Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about 3D printed homes in 2023. I've already covered this topic like 2 years ago, so let's take a closer look of what it is now. Now, just to give you an idea, it's a simple reality that humans need shelter. We need homes, we need houses, and this desire goes back to thousands of years and thousands of years in the future also. So it's one of those things that is always needed, is needed, will be needed. We do not have to worry about it. And ironically, even with so much development in technology for past 200 years, we still using handmade technology. Basically, at this point in time, we are still doing this. And this is bricklaying competition in Britain. Uh, these people do look like superhuman when they are laying that many bricks. But the idea is the same. Everything is still at this point is handmade. We have not made that much progress here. Now, what do we desire at this point in time from a building point of view is cheap and fast, meaning not only we should be able to make it in less duration. For example, you can do reduce cost of brick houses if you are willing to work at a smaller crew. Consequence, your time will take longer. Rather than taking, let's say, 6 months, it may take 8 months or maybe 12. So we want these two things happening at the same time, meaning we want it to be low cost while being fast, cheap and fast. That's both things that we desire. Now, 3D printer does do that. 3D printed homes does achieve these two factors while being less wasteful, because it's only using material that it needs and it's not wasting things. Like from a practical point of view, wastage on the construction site is exponentially less compared to any other method system. So that's good, and that itself is not that big of a deal. But the big deal is that they are very energy efficient, meaning how the building structure is built, it does have very good insulation property, and benefit of that is that your air conditioner, your heaters, they have to run much less comparatively speaking, so you save on energy, and that's a exponential benefit over time, meaning it's a, oh, you saved some amount, like over time it piles up a lot. And if you're running on solar, that's awesome. So this is the desired idea for us, that we have a home that is built quickly and that is built cost effectively while having better insulation property than all other designs. So what tools that we need? Well, ironically, it's super simple CNC, meaning inherently, if we really wanted to build this, we could have built this as early as like 1970s. But we had no desire or even thought of that. Like 3D printer is ancient technology. It's just that we never had use for it, and not to mention patent lock and all that jazz was also there. So can we have built this years ago? Absolutely. But we didn't. This is the first time that we are truly trying it. So what is it? At the end of the day, go to the base level, is just automated gantry crane, meaning somebody looked at this, somebody looked at a CNC, and they decided make them together, make them make a baby. But this is a big baby, normal CNC is a small baby, so they made a medium baby, and that was the key, a medium size CNC gantry. Like we have huge ones, these puppies are big, powerful, capable. We don't need something this powerful. So we need something that is a bit bigger than normal CNC, but not as big as gantry crane. So we need something in between. So this is what we built, and there are two ways. Like you have on-site gantry printers where you put two track rails, and that's it, you built in open. Or because some scenarios you may have too much temperature variation, you may have too much wind, you may have too much rain, all those things may make this sort of system not viable, or you may require to erect a giant tent. You may be like, hey, what about I built a enclosure, large enclosure, in that enclosure I built this 3D printer and print out houses in blocks. Both are options. So each options will give you something and remove something. For example, this option inherently would be slower, meaning building parts and shipping it inherently would be slower compared to building it on site in one go. However, this will be inherently more expensive because the printers are expensive, and you may require to erect a tent, like a tent that is size of a house. Again, thankfully we do have technologies to do it. It's not cheap. It can be done, it's just not cheap. And like, I really want to see a tent that is size of like 2 or 3 story building. It would be interesting to see. Can be done. Let me be very clear. Can it be done? Yes. Can it be done cost effective? I don't know. So that's the interesting part. So this is an Indian system where they have built a basically giant warehouse which is completely controlled, and you don't even need weather control. You just want to be like a giant wind gust not coming in, like and sun getting too hot. Like, a basic climate control is more than good enough. So they are building blocks and then they are shipping it. So block has to be size enough where you can ship it in using normal road transport, and then you attach it at the point of construction. Done. This, you do need a bit bigger point of construction because of course this printer will be larger than the house that it is building, so you do need left and right clearance and top clearance. It's kind of easy when you're talking about house. So tools are surprisingly simple. So let's talk about deployment. And here's the India and the whole world, they have many projects going on, and many projects are deployed, meaning people are in there using it. It's not just a lab project, not something that is done in basically institutes, MIT, IIT, things of that nature. I'm talking about things that are used by common people like you and me. So we have a 3D printed post office in Bangalore. Yes, it's a post office. Do not ask me why it's being done, but it's being done. And you can see that this is a 3D printed gantry system. Basically, it's built in one go. And I have linked news articles of down below, the video of this place. It's it's one go. It's gonna take less time while costing the same as it would have been like compared to normal system. I'll explain why that cost matters so much. The cost is same if they had built it with normal brick and mortar system. And this is basically two-story building that is made of 3D printed house in Ahmedabad from Army Engineering Corps. Basically, Indian Army has a core that deals basically engineering technology. They are deploying this. This has been deployed in Ahmedabad. Now, interesting part of this was using the same technology of building modules, then carrying that forward and attaching it. So you design the module as you need. Basically, you design a 3D house, slice it in small blocks. That blocks gets printed. Then you bring it here and assemble it, and voila, you have 2D print house. People are living there. Awesome. Then you have 3D printed runway controller hut in Pune. That's a Pune airport that has a 3D printed controller hub. And again, these three things that's the easiest I could find. And there are many, many, many more. Indians are awesome at making things. We are really horrible at capturing them properly. Like, good luck trying to find good high resolution images of that. Even in the era of Instagram and all that jazz, we really do not have like inherently good technology of, okay, this is a thing, I'm going to capture it, I'm going to store it, this is an amazing technology. It's just that I would not be shocked if someday tomorrow in future India is like, oh, we built this technology. Sir, what is the coverage? Like, can we learn from this? Like, yeah, this is the paperwork. It's like, no, sir, footage and all that, nothing. Like, go to ISRO website. They have amazing things. It's like, yes, sir, photo, good luck. Good luck with that. So, and yes, I'm talking about India, but there are many, many, many projects worldwide. So this technology has left the lab. This is in early deployment, meaning we have reached, roughly speaking, 3G mobile phone. Basically a mobile phone stage where people actually started to use data on mobile phones. So deployment has been done. And both technology, basically building blocks and building giant buildings. And AI-assisted technology would be the next step for this, basically 4G of this technology. The reason for that is right now we are using Mark 1 of this technology. This has just left the lab, just in the market, and we are doing it. Okay, awesome. Everything is awesome. But here's the same thing happened with 3D printers, meaning I'm very old. Basically, back in the days, I used to watch what we call Ben Hack Show. It was quite amazing show. Came into internet TV, basically Revision 3 TV network. Internet TV network, and they built 3D printer. That was awesome. I thought like someday I'm gonna build my 3D printer. I bought it, and here's the deal. The 3D printer of then versus 3D printer of now, ironically same. Even the controller is the same. And they were using 8-bit. Yes, nowadays you can use 32-bit, but you can still buy something that is 8-bit, and most likely there is only 8-bit computers. And all things considered, like the motors are the same, the timing belt, the bearings and all that, nothing changed that much. Like printer-wise, hardware-wise, nothing changed. But what did change in last 10 years is the slicing algorithm. The algorithms that we deploy in our day-to-day projects is exponentially better. Like some people have done experiments. Basically, they take old printer, took a modern day slicing software, create the slice, basically tool path, feed that in, output is 10 times better. And that's the next step for us. AI would be needed for that. Now, be mindful, when I'm talking about AI, I'm not talking like a human level AI, but something very complex. Like, is there a rudimentary intelligence in your basically slicing software? Absolutely. We just need some bit more oomph in that. Because once you have better slicing software, it will improve your throughput and physical properties, because all the algorithms that I'm seeing right now, it's all very basic. It reminds me exactly how slicing algorithm used to work in early 2010s. Like, it's a very simple algorithm. It's like, oh, tick tick tick. It's like, it's not adapting to it. It's not adapting here. This is how the thermal properties could be. I could easily see very almost like fluid kind of dynamics, where printer could be like, hey, I'm laying the base floor, so let's make it thicker. I'm making the upper floors, let me make it lighter. Hey, this place will not be exposed to the outside sunlight. How about I make this place in such a way that it has very little footprint, so people are using it. It's like right now it literally feels like somebody Control-C, Control-V'd our old building tactics into a 3D printer. They have not adapted the 3D printing aspect of it. So the wall thickness does not change. It's like, dude, it's a concrete paste. It does not need to be as thick. It's like, but I think the thickness literally came from the bricklaying industry. So bricks were this thick, so we had this and this, like, 1 brick, 2 brick. and all the walls that I'm seeing is like 1 brick or 2 bricks. Like, why? You don't need to. But again, this is a Mark 1 technology. It will always happen. That's why I said, look at the 3D printing 10 years ago, 20 years ago. It was the same. The technology was there. It was just that the slicing algorithm was not that good. Now we have like adaptive slicing algorithm that is like mind-bogglingly awesome. For example, this is a slicing algorithm where they have tilting nozzle in 3D printer, and it can literally print horizontal without support. It can be done. So same goes with this. I can easily see these things are right now in what I will call just fill in the lines. What I'm expecting is like, hey, adapt to things. So it can have electrical conduits layout places. It could have different places where it has a plumbing, accommodation. All those things that can be done. So that will be the better upgrades of it, and that will also improve thermal performance. That's why like thermal performance of these things are very static. They're not adapting. It's like, oh, this is the outside wall, this will be exposed to the sunlight majority of the time. This is the sun facing wall, this is not the sun facing wall, let's make it basically less conductive in a sun facing wall. If again, you can do 10,000 things, you can design the thermal property of each wall independently. We are not doing it. So again, it will make it too complicated. That's why it has to be done by AI. Basically, the slicing algorithm has to become very, very advanced. And physical strength. Physical strength is very important, because right now the buildings that have been built in like a Richter scale 5 kind of earthquake zone. We want something that can withstand, hopefully, Richter scale 6. So be mindful, this Richter scale is kind of weird because it's exponentially more power. So if you're like 5 to 6 is like a little bit, no. 5 to 6 is like 5 is like bad, 6 is like bye-bye. So we do need to adapt this sort of thing. And I do expect it to take some time. And then we'll be able to have a scenario where designers, architects won't be needed. Meaning you're going to have a design in your mind, you're going to scribble something either in text or just scribble it on your iPad or something like that, and it will go to AI. AI will literally create a rough design out of it, and then that rough design will be sent to you, and you will fine tune it. It's like, you know what, this place, I think I need something different or something different, and then AI can adjust to it and may even suggest to you. It's like, bro, the fridge location, because again fridge dumps heat, it may compensate. Hey, put fridge on a place where it's very easy to dump the heat outside. Or maybe you are living in a cold place where it's like, hey, put fridge in a place where the waste heat of the refrigerator is dumped into the household. Both can be a desirable situation. So AI can work with you to literally bring out vision literally out of here, and voila, a 3D printer. Then it will go to other slicing algorithms, your house. Then it will go through other AIs that are being worked in, to figure out the building codes and all that jazz. Voila. So any Tom, Dick and Harry, as long as they have deep pockets, should be able to just make a house. Of course, they will call up someone. It's like, bro, engineers, bring up the 3D printer, assemble the 3D printer, voila, your buildings. Of course, so far I've seen foundation being still done manually, but I'm pretty sure it can be automated if people want to. If it's too expensive, then people will automate it. Right now, it's not that expensive, so I don't see any reason to automate it, but it can be done if needed. So AI will make it very approachable for every Tom, Dick and Harry, and just like it will also allow you to make buildings that are based on certifications, building codes, all of them will be followed. So that's the next stage. That's the stage of taking basic 3D printers, making it damn good 3D printer. From this, like lab quality, very basic algorithms to adaptive algorithms that we cannot even think of. So what we can expect in the future? Well, reality is it's one of the oldest sector. Like in terms of sector, house building is a sector that always was there. Like I'm talking hundreds of years ago or thousands of years ago. It's one of those things like human realized to improve from animal kingdom to like our level, we had to create shelter. Shelter was important. Basically a static place that can withstand everything. Summer, winter, rain, snowfall, whatever have you. So we literally spend generations fine-tuning this technology, creating a sector, and I mean everywhere around the world. And that's why like you will have building codes that are unique to that location. People living in Afghanistan, they have their sort of feeling about it. It's like, this is how we build, because again, our environment requires this. You come to India, people are building houses that are in Indian style because that's what it works here. You go to America, people are building like that. You go to Europe, people are building like that. So it's one of those sectors that will be changed forever and irreversibly, because once it actually starts to work, there is no point of going back. Because yes, many times if you look at technology, it gives you something but it takes something away from you. Sometimes they're like, would you like to have a home handmade cars? People are like, yes. Why? Those are generally higher performance than factory made cars. So if you have a handmade car, like let's say Bugattis and all that jazz, those are super high performance, but they have to be handmade. That's the consequence. So you are gaining performance as a handmade option, and you're getting, reliability, stability, mileage, and all that jazz in your Toyota and all that. So you have two options. Here there is no valuable like that. Basically, can you have a handmade house? Yes. Will it be artistic? Hell no. Compared to a 3D printing algorithm? No. So there is nothing there, and not to mention it's cheaper and faster while being artistic. So, so it's one of those things that is like, these people do not bring anything unique to the table. So that does create a scenario where it's one-way change. It won't be like, oh, these people will go into like, making more far out ideas. It's like, no, 3D printers can go there. 3D printer can do the basic Toyota and Bugatti Veyron. So it will change irreversibly. And we'll get faster and better homes, hopefully. But here's the deal. Because this technology is new, again, I'm saying about like buildings being built and people are living in there. That's done. That's true. Awesome. But we do not have long-term data. And I did specify homes, we have centuries of data. Like, you would be shocked how much knowledge is there in every brick layer. It's like how the heck they are laying bricks. We literally have thermal expansion and contraction into brick laying. I did not even knew about this, but like, that's a technology that we know. It's so basic that we don't even think about it, and people know. Every bricklayer inherently knows how to lay it properly, and there is code for that if you really want to. And again, we had hundreds of years of research and development. So figured out, oh, if you don't do this, water will destroy your house. If you don't do this, basically summer and winter will destroy your house. We have learned it the quote unquote the hard way. In this sort of 3D printed era, we do not have enough data. We can have accelerated aging testing, but that does not simulate everything. Especially, it does not simulate humans. So it's a good thing. It's a good start, but we do not have long-term data. And the only way to get that quote-unquote long-term data is to be in the long term, meaning we build these houses, expect a test result in 50 years from now, and then we'll know like this is a truly good long-term investment or not. So that's the slow part, but everything else is like more than good enough. And investment in this field has gone up exponentially. That's why I was specifically focused on India. If people in India are doing good luck, like this is a project that is in USA, I think USA. Yeah, and they are building 100 3D printing homes in a whole neighborhood, and they will be starting sale in June 2023. So that's the future. Future is here, and we are just waiting for technology is here. We are just testing the long-term data at this point in time. And it will change building industry permanently. So this was my presentation on basically 3D printed homes and its development in recent years. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help you a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.